Thank you. So my name's Matt Hamilton. I'm a developer advocate at Protocol Labs. We are generally known for Filecoin, IPFS, a number of other technologies like libp2p. It's a networking protocol that's used in about a dozen different blockchain systems. So today I'm going to be talking about building projects kind of unique to the Filecoin ecosystem. So Filecoin has in the context of this hackathon here, Filecoin has a virtual machine, FVM, and FEVM that allows you to deploy Solidity contracts to Filecoin. Well, that's all great. That's just like any other EVM type of blockchain. But what sort of interesting things can you do related to Filecoin, related to storage? And I'm also going to talk about some exciting upcoming tech that we're demoing here as well and previewing. Very much cutting edge stuff, but there's some really interesting stuff there that people might want to take on. So I'm going to quickly go through, just to set the scene here, some of the challenge statements. We can go over this again later, so I'm going to go through this relatively quickly now. We've broken it into a number of categories. So we've got programmatic storage. If anybody was in the talk by our friends from Lighthouse, Lighthouse is a storage aggregator that stores data onto IPFS and Filecoin. They covered some ideas with regards to programmatic storage as well. So things to do with automatic renewal and repair of data. We've got a service called RAS, which is a set of contracts that allow you to indicate that you would like a particular piece of data to be automatically renewed at the end of its storage lifetime on Filecoin. Data DAOs, so decentralized autonomous organizations in which they manage data. So this might be you have something in which you want to upload some data and have it collectively managed by a group of people. Maybe you even have something like an endowment fund that generates passive income through some other mechanism within Web3 and uses that income to then pay for the future storage of data on Filecoin. State storage integration. This is a kind of concept that we're showing here that allows you to, on FVM or any other blockchain actually, pull data in from things like IPFS and Filecoin. So it's more of a sort of a pattern and an interface to use, but you can use it very flexibly on multiple different blockchains to pull data into smart contracts. DeFi, so one of the unique things about FVM and about Filecoin is a huge network with a large number of storage providers on the network. The network is a total of about, I think it's about 11 exabytes of data at the moment. It's about 1% of the entire data center storage capacity worldwide. And that is a large amount of infrastructure there. You may have heard the phrase DePIN, decentralized physical infrastructure. Well, Filecoin is probably one of the largest examples of DePIN around. It's also, coincidentally, one of the largest implementations of zero-knowledge proofs, something that some people might not realize that Filecoin uses zero-knowledge proofs, has done for about the past 3 years, and it's probably the largest production implementation of zero-knowledge proofs out there at the moment. But yeah, with all of that infrastructure out there and all of that effectively equity within the infrastructure, it gives rise to some really interesting DeFi models, because these storage providers have storage deals that they may be getting paid for, and they might want to borrow the Filecoin token fill in order to pay collateral for those storage deals. Conversely, they might want to either lend against future revenue that they might have, or they might want to borrow as well from that. And then we get on to new tech breakthroughs. This is the bit that gets really quite exciting. Be warning, there be dragons. This is really cutting edge stuff here that we're working on. Anybody who was in Phil Bangalore will know this because I went to demo some of it. But we have got the Mycelium testnet up and running now, so you can have a go with it. So there's a couple of new things around IPC, which is Interplanetary Consensus. So IPC allows you, I'm going to cover this in a little more detail, to have subnets on the network. So individual networks that come off of the main network. So think of it like layer 2, but in a recursive fashion. Layer 2, 3, 4, 5, you can have multiple subnets there. So like I said, I'm going to cover that in a bit, but this gives the ability to be more flexible. So you could create a subnet in which you replace the virtual machine runtime on that subnet. So you can replace FVM that we have on there, or rather FEVM, which is the Ethereum layer on top of the Filecoin virtual machine, with another virtual machine. So something like Moves VM or Poker VM, Solana VM, for example, you could implement on top of that. Now, it's a lot to do within 36 hours, but I know that some people that are up for a challenge, it would certainly be interesting to see people kind of have an attempt at that. And with these new tech breakthroughs, we're going to be a little more lenient on the judging on them, because we know that these are real stretch goals. So people that make a a valiant attempt, even if you don't necessarily cross the finishing line with what you're doing, but you show some very significant progress and learning, then we'd be very interested in that. So new runtimes, also large-scale applications. So using things like blockchain for gaming. So for example, things like turn-based games. You could make something like a simple, like a board game, for example, and you could use a blockchain for that. You could use a subnet for that, because we're reducing the block time right the way down to a couple of seconds, and so you could actually use that as part of storage and part of the logic system of a game. So onto a little bit of backgrounds. That's the bounties kind of gone through, and we'll go through those again later. But Protocol Labs, like I said, you know us mainly from probably the three biggest things we're known for are IPFS, Filecoin, and libp2p. People that use any of the technology that we have developed there up here are eligible for bounties, including some of the storage aggregators like NFT Storage and Lighthouse, and the CDN that we have, Saturn, that is a content distribution network for Web3 as well. So bonus projects for building out unique ideas. Please don't just go and store a little bit of data on IPFS and come to us. It needs to be something more than just IPFS, right? If you're using one of the storage aggregators, like I said, Lighthouse NFT Storage, that's fine. We'd really love to see something more exciting than just storing a little bit of data on IPFS. It's one of those kind of almost unfortunate paradoxes that we have. IPFS is so simple to use, which is great, but on the other hand, it means that sometimes we can get some projects that are not as exciting as they could be, because one line of code to store something in IPFS, we'd like to see somebody stretching things a little bit further if they can do. So the Filecoin master plan, build the world's largest decentralized storage network. We've done that, and that's continuing to grow even more. Onboard and safeguard humanity's data. We have a number of projects that are pulling in large-scale data from public archives, research organizations, that kind of stuff, to be stored on the network. We're also looking for people within the Web3 ecosystem to be using Filecoin as well for storing data. And then the next stage is bringing compute to the data. So you can kind of think of this as a bit of an evolution. Where we're talking layers here, we're not talking layers quite in terms of layers like as in blockchain layers, but more as in sort of conceptual layers. So if you think about IPFS and libp2p as being kind of the ground layer on which a lot of these technologies are built, and then we've got things like layer 0, the Filecoin blockchain itself, and then layer 1, the FVM, the Filecoin virtual machine, and that allows you to do compute over state of data. So this is just something to be clear about. With Filecoin, the actual data itself is not stored on a blockchain. There's no way we could be storing 10 exabytes of data on a blockchain and getting consensus on that globally. So the data itself is stored off-chain. What is stored on Filecoin is the metadata, the accounting data, and the proof that that data is actually stored and is safe. So FVM allows you to do computation around that and logic around that state. So how long is something stored for? Is it still valid? Can I instigate a renewal of that data or replication of that data? That's all kind of things around FVM. And also, like I mentioned, DeFi, things like loans, for example. How much storage capacity has this storage provider got? And could I use that as collateral for a loan? And then we get into like layer 2, which is IPC, the Interplanetary Consensus, and that allows then really performant dApps with chain scalability. Scaling both horizontally, so you can create multiple subnets and scale horizontally, so that might be regional scaling, or it might be scaling based upon a particular application, for example, or use case, or vertical scalability. Because with IPC, you can actually chain blockchains and have layer 2, layer 3, layer 4, etc. going down. I'll talk a bit more about that in a bit. So I mentioned FVM, on-chain programmability. I mentioned about how FEM manipulates and allows you to interrogate the metadata around the storage deals on Filecoin, allows programmatic storage with smart contracts like RAS. So if you saw Lighthouse's talk earlier, they showed an example of using RAS, which stands for Replication as a Service, or Renew or Repair as a Service. And they demonstrated using a smart contract to actually instigate that logic around renewing storage there. And the FEM, the FEVM layer on top is fully EVM compatible, so you can use MetaMask, Remix, all your standard tools, Hard Hat to work with it. So here's a developer resource for programmatic storage. If people want to grab that QR code there. So that will take you through to, I think that takes you through to some documentation on Lighthouse on how to use RAS with it. We also have a renewal as a service starter kit as well within the Filecoin project on GitHub. So the RAS starter kit can help there as well. Then another example is data DAOs. Now I'm going to actually, yeah, I think I've got time, do hopefully a very quick demo of a data DAO. So like I said, a data DAO is a decentralized autonomous organization that can deal with the management of that data. So what we've got is an example where we're using a governor smart contract. That's a standard contract from the Open Zeppelin project that's used by many DAO projects. And what we're going to do with that governor contract is we're going to submit a proposal. And that proposal is to store what's called a CID, so a content identifier, on the Filecoin network. So this is something that's already stored on IPFS somewhere, and we want to store it on the Filecoin network for longer-term archival, verifiable storage on there. So we're going to make a proposal to this governor contract. Now, this governor contract, for the purposes of this demo, is only going to require one vote for this to be approved. And the voting period is only going to be 3 minutes, right? Typically, you'd have something longer and more in depth. And once that's approved, you can then execute that proposal. And executing that proposal will then cause it to be sent to Lighthouse's RAS contract and then stored via Lighthouse onto Filecoin. So I can give you like a little quick demo of this. I've just deployed these. You can see here with Hard Hat, I've just deployed these contracts. And so the next thing I need to do, if we look at the documentation here for the Data DAO kit, it gives us an example here. So I am going to propose a particular CID to be stored on the network. So if I clear that and put that up there. So yarn hard hat propose, I give it the CID and I give it a reason. Hello, Bengaluru. So I'm going to do that. That is going to propose that to the network. That's going to take a little while to actually execute on the Filecoin network. So in the interest of time, what I'm going to do is I'm going to skip forward a few slides, talk about a few more things, and I'll pop back to this demo kind of as we're going along, okay? So this is making a proposal. Once we've made a proposal, we're going to vote on it. Actually, maybe what I'll do is I'll just wait until this goes through, and I'll execute the vote, and then we can move on. So going back here, we can see there's a vote command. And in the vote command, we need the proposal ID. That proposal ID is going to come out of this proposal command. So we'll see in a minute. Once this finishes executing, we'll get a proposal ID, and we'll feed that into the next command. Like I said, this is all in the Data DAO starter kit. The QR code is there if anybody wants to grab that to follow along with this. This will be a good basis for if you want to try and do some things here regarding managing data. I've talked to some people that are interested in things like refi, some interesting examples with regards to storing data for conservation purposes, for example, that might be interesting here. So that's finished. It's come back with a proposal ID. So if I just paste in this vote command, I'm just going to replace the proposal ID there with the one it's come back with. And that's going to now vote. So we have 3 minutes to vote. So this vote should go through within 3 minutes, and after 3 minutes, I can then execute the proposal. So whilst that's waiting, I'm just going to continue on here. I'll talk about the system state storage. I mentioned this right at the start with the bounties. So state storage, again, there's a QR code that will take you there to a state storage starter kit that we have. And this is a mechanism by which you can request that some data from a CID be loaded into your smart contract. Now, obviously, bear in mind you don't want to load huge amounts of data into a smart contract because you've only got limited processing within Solidity and costs, gas fees, memory usage, etc. Again, you don't want to be loading too much. But if you have a small CID that is under a single chunk size, I can't remember exactly what a chunk size is on IPFS, a few kilobytes, I think, you can request that that be loaded in. So what happens is you have a smart contract with a method called request blob load, and you pass in the CID a reward that you want to pay, and you could implement a reward function within this as well on a timeout, and that emits an event that is listened to by a little daemon that you run. If you look in the starter kit, there's a little JavaScript daemon that you run that connects to the network and listens for that. And when it gets that back, it fetches that CID from IPFS. You have to run a local copy of what's called IPFS desktop in the example we've given. Obviously, you can extend that to do whatever you want to do. But if you've got local copy of IPFS desktop, it'll communicate with that, fetch that CID, and then call this deliver blob method and pass in this thing called a correlation ID that it gets and the actual payload of that CID. And it will validate that that data is valid, because a content identifier, if you're not aware, within IPFS and Filecoin, data is referenced by a content identifier. That is, in simple terms, a hash of the data. So if you have the content identifier, if you have its address, you can verify that the data is in fact intact, and the data that you requested is actually the valid data, because you can actually take a hash of that data, compute the CID, and see if that matches what you requested. So you can do that and get the data in, and then you could do some processing on that within Solidity. Let's see how our vote is going. So our vote's gone. I'm going to now do I'm going to execute, and the execute command looks very much like the propose command. And so hopefully our 3 minutes is up now. The voting period is over. If it hasn't, I'll get an error here telling me that voting period is not quite over. In this case, it looks like it is. It's going through. So this is now going to execute that command and send that CID off to Lighthouse to now go and get stored. And I don't know if we'll have time to see it, but in a bit we can probably check the Block Explorer, and we should be able to see that having gone through. So, state store I mentioned. Oh yeah, this is just a diagram of kind of outlaying what I mentioned here. You have a client DApp, so looking at the yellow boxes along the top, a client DApp, you have what's called the data management smart contract, that's included in the starter kit. You have a data relay daemon, again, that's included in the starter kit. That just fetches locally from a local IPFS node and fetches that data from there. So you see kind of going through the top here, we go from the client to the smart contract to data relay daemon to IPFS, and then the data comes back basically the opposite direction back through there. So, but in that starter kit, there's examples there you can basically play with. So on to some more exciting stuff, interplanetary consensus. So interplanetary consensus is unlocking basically web scale, or planetary scale performance for Web3 apps. And like I said, both horizontal and vertical scalability. There's a couple of QR codes here. The top one will take you to an IPC Docker image that's made by the developer experience team, the DX team that I'm a part of. That will allow you to get started fairly quickly using just Docker. Be aware it will download a fair bit under Docker. And then there's the IPC docs, that's the next QR code down. They'll take you to the documentation about IPC as well. There's a lot more information there. We've got here, so this is the docs here. That QR code will take you to, within the docs, we've got a couple of quick starts that allow you to do things like deploy a smart contract to IPC. So we have a public testnet called Mycelium, and you can just configure MetaMask. There's instructions there how to configure MetaMask to point to Mycelium, and you can deploy to that just like you would do any other layer 2 or layer 1 network. But where it gets really exciting is you can deploy your own subnets. So you may be able to see on the right-hand side here, we have a number of subnets that kind of come off of the root network. Each subnet is its own entire complete blockchain. So in IPC, it uses Tendermint and Comet BFT for the consensus protocol. And you have a number of nodes running there. They are a complete working blockchain in and of themselves, right? We actually have in that DX container, you can actually run a local, what's called a test node yourself, that is an entire subnet that's not even anchored to any other network. So if you want to have a play around with something locally really quick, you can deploy a test node and interact with that. But you can anchor the subnet up to a parent network. So in this case, you could anchor it up to Filecoin, but actually it's you could anchor it to any EVM network. I was talking to somebody from Polygon who was interested in anchoring it to Polygon. I said, yeah, sure, give it a try. So that should work. Periodically, the subnet then checkpoints its chain state up to the parent subnets, and that's how you get effectively the long-term security there from the parent chain. So you can use IPC to shard applications or shard a network into either subnetworks per application, or potentially per geographic region, for example, on there. So here we go. Here's an example here. We've got like main nets, layer 2 networks, layer 1 networks at the top, and then going down to things like you could have a gaming subnet or a database subnet, and then maybe different games, and then, for example, regional subnets underneath there as well. The ultimate goal that we're aiming for with this is that these IPC subnets will be so lightweight, you'll actually be able to run a subnet node within your browser. It's not here yet. That's the direction we're going, though. But that'll give you a bit of an example as to what might be possible. For example, you could have a game in which the main long-term game state, imagine things like the high score table, for example, are stored in a regular subnet off of IPC. Maybe where we have, one of these like game A, B, or C along here. One of those could be that game, right? Then when a group of us go into the game lobby and start a game, maybe a dozen of us start some kind of interactive game with each other, then each of our browsers could spin up an IPC node to create a subnet, an ephemeral subnet that just lasts for the duration of that game. Now that game subnet could be responsible for just things like our score within the game we are playing, enforcing the rules and the consensus within the game we are playing, making sure that one of us is not cheating, making sure that in-game currency or items can be passed between us in a secure and fair manner. Once we get to the end of the game, somebody's the winner, say, their score could then be propagated up to the higher subnet, that is the longer running subnet, and the subnet that's within our browsers, the ephemeral subnet that was just for that game, can be discarded. Right? We don't need that anymore. That was just around to ensure that the game play was fair for the duration of the game. But the actual long-term artifacts of that, like the high score, for example, could be passed up to a longer running chain. So that's a kind of an example as to where this kind of all fits in together. Thank you. So just to reiterate, going back to the challenge statements, I'm just going to bring up again the new tech breakthroughs one, because like I said, we've got a number of challenge statements here. Most of which, if you've been to any of the other ETH Global hackathons or ETH Online hackathons, may be familiar to you. But we've got some new stuff. Like I said, there be dragons. This is stretch goals. It's a lot to potentially do within 36 hours. But if somebody wants a challenge, then by all means, take it on. We could look at things like I said, new runtimes, larger scale applications, running games, that kind of thing on there would be really interesting to see. So that's everything. Thank you very much. And if anybody has any further questions, I'll be just down and probably just at the entrance of this room here. Myself and Juan Benet, founder of Protocol Labs, who's just sat here in the front, will be just stood outside here if people have any specific questions. We've also got the Filecoin booth, which is directly opposite here on the far wall. So you can come and chat to us, come get some swag as well. Okay, thanks very much.